Good morning, student. Namaskaram. Today we are going to discuss from topic from 12th physics. So 12th physics unit name, that is chapter name, current, electricity, and topic name Wheatstone bridge. Okay. So this is one 8 mark question. Okay. So before going into that Wheatstone bridge, we have to know basic two law that belongs to current electricity, that is Kirchhoff laws. Okay, so Kirchhoff's laws. So there is a first law and a second law. So first law, Kirchhoff current law, also known as Kirchhoff first rule or first law, uh, current rule, junction rule, lot of name for that this rule. So Kirchhoff first rule or first law, current rule, junction rule. Okay, right. So which state that the total current enter into the junction must equal to total current leaving the junction. Total current enter and total current leaving. Okay. So I total current entering the junction must equal to the total current leaving the junction. So it is also said that the algebraic sum of the currents at any junction of a circuit is zero, because suppose one junction is there, one current is entering and one current is leaving. Okay, so one equal to one, because one current entering, one current leaving from to this junction and away from the junction. So algebraic sum of that two currents at any junction of a circuit is zero. So this is a first law, that is Kirchhoff current law. And Kirchhoff second law, already we know that what is Kirchhoff second law, first law. Okay. Anyway, I can remember again. So second law or voltage law. Okay. Voltage law, voltage rule, loop rule. There is some name for this law also. So which said that total sum of all voltages around any closed loop in a circuit must equal zero. So this law belongs to voltage. Okay. So total sum of all the voltage around any closed loop of a circuit must be equal to zero. So these are the two rules we have to know before enter into that Wheatstone bridge. Okay, right. So next Wheatstone bridge circuit diagram. So Wheatstone second law, algebraic sum of the changes of any voltage, any closed circuit is equal to zero. Current rule or first rule, uh, entering the junction current must be equal to the leaving that junction current. Okay, right. So Wheatstone circuit diagram like that. So G, is resistors. Okay. This is A junction, this is B junction, this is C, this is D junction. This is galvanometer. Okay. Current I1 pass here because here battery. Yeah. Already you know that battery. So it has one EMF plus E. Okay. Plus minus. So current passing like that plus 2 minus conventional current. So I1. So that current is separated into two components because of this junction. So this is I1, this is I2. And this current goes here. So this is I3. This is I4. I4. And the current passing through this galvanometer is called as IG, galvanometer current. And the resistance, this is R1. This is R3. This is R2. This is R4. Okay. So 4 resistance. So Wheatstone bridge. The circuit zone in the figure is called a Wheatstone bridge. It has 4 resistor R1, R2, R3, R4. And AC battery is here. And here BD is junction BD. The galvanometer across that junction B and D. Okay, galvanometer is connected across the junction B and D. Galvanometer is a device which detects, which is used to detect the current in the circuit. Yeah, already we know that. Yeah. So galvanometer is a device which is used to detect the current in the circuit. So if the resistor are adjusted such that galvanometer current Ig is equal to 0, then the bridge said to be balanced. Okay, this is a condition, balanced. We have we can adjust that other resistor to become Ig equal to 0. So once Ig is equal to 0, galvanometer detects 0 deflection, null deflection. So that condition is called as balance condition. Galvanometer does not show any one direction deflection like that or like that. You should be in middle direction, that is 0 0 value, that is null direction. That is called as null direction. Okay, null deflection. So that condition is called as balanced. So after balanced condition arrived, then we can move into the next step. Applying Kirchhoff junction rule at B and D. Already we know that junction rule or current rule, first rule. Okay. So applying Kirchhoff first rule at B. Already we know that the current entering into the junction and must be equal to the current exiting that or leaving that circuit, leaving the junction. So I1 entering, Ig leaving, I3 leaving. Yeah. I1 leaving, I1 entering, Ig exiting, I3 exiting from at B junction. But Ig is equal to 0. Already we know that Ig is equal to 0. So we can neglect this term. So I1 is equal to I3 for this position. Okay. By using the Kirchhoff junction rule or first rule. And again, applying the Kirchhoff first rule, again, this position or this junction at D. In this junction, the current entering into the junction is I2, current exiting the junction I4, and also Ig also entering, but Ig is equal to 0. So we just put I2 and I4 only. That is enough. Yeah, because I2 entering, I4 leaving. So that current must be equal to that leaving current. Now we have to apply Kirchhoff loop rule. Loop rule, also known as voltage rule or second rule, across the closed loop, that is ABDA. ABDA. For this closed loop, we have to apply Kirchhoff loop rule. That is second rule or voltage rule. So in that condition, in that loop, voltage rule becomes like that. Current into resistance means voltage. Yeah, I1 into R1 plus IG into G, because like goes like here, A to B, B to D, and D to A. So if we are moving like this, the current goes along with our direction, but from this position to this position, current against that our direction. So in that case, so we have to put minus sign, current into resistance, because current into resistance voltage, that is called as voltage rule. Okay. So voltage, we have to find voltage across the junction. So for our direction, for along with our direction, we have to put positive sign. If against the, if we measure that direction with against the current, so in that case, we have to put minus sign. So here A to B, D to A. So current is against our direction. So I to R2, which is equal to 0. So all, okay. So which is equal to 0. So like into R2 equal to 0. Okay. Right. Again, in that equation, we can neglect this term because I is equal to 0. Yeah. So we can neglect this term. And in this term goes here. So I1 R1 equal to I to R2. The minus sign goes vanish and it becomes as plus. So I1 R1 is equal to I to R2. Yes. So we can go, uh, we can write like that. I2 goes here. So I1 by I2. R1 goes here. So R2 by R1. Okay. This is current. So this is equation take us 3. Already we have a I1 equal to I3 is 1. I2 equal to I4 is 2. And this is the third equation. Again, we have to apply Kirchhoff loop rule on the C, B, D, C. That loop. That is also loop. C, B, D, C. Okay. So in that case, so I1 by I2 equal to R2 by R1. Okay. We can take only result here. So now we have to put Kirchhoff loop rule to this C, B, D, C. C, B, D, C. So from this position against the current, so we have to put minus sign I3 R3 and goes here and goes like that. So IG into G, and from along that with the direction current, so I4 into R4, which is equal to 0. Yeah, correct. Now you are familiar with that. We can neglect this term because IG is equal to 0. So only this term, these two terms arrive. So this I3 into R3 minus sign goes like after that equal. So it becomes as plus. So I4 R4 equal to I3 R3. Clear? I4 R4 is equal to I3 R3. Already we know that I3 is also I1. I4 is also known as I2. Yeah. So I3, I4, sorry, I4, R4 and I3, R4, R3. In that equation, we can replace I3 with I1 because by Kirchhoff current rule, we have this. equation. And I4 replaced by I2. Okay. So in that case, the I2 goes here like that, I1 by I2. So R3 goes here. So R4 by R3. Okay. I1 goes here. So I1 by I2, R4 by R3. So we can write like this. So here also we get I1 by I2 equal to R4 by R3. So already we have a I1 by I2 is equal to R2 by R1. Now we have also I1 by I2 is equal to R4 by R3. So left hand side equal, right hand side also equal. So this is equal, then this is also equal. Yeah. So R2 by R1 equal to R4 by R3. Okay. So R2 by R1 equal to R4 by R3 because of left hand side equal, right hand also equal. Equate these two equation I1 by I2, I1 by I2. So this is R2 by R1, this is R4 by R3. So which is equal. Okay. We can reciprocal to this equation. So we can get like this. So here also reciprocal. So R1 by R2 equal to R3 by R4, which is the balance condition. This is a balance condition of Wheatstone bridge to make Ig is equal to 0. Okay. This is a balance condition. This is a balance condition. This is a condition for bridge balance. Only under this condition, galvanometer shows null deflection. So that's says it shows null deflection. Null deflection happens when the Ig is equal to 0. Suppose we know the values of two adjacent resistor R1, R2, or R3, R4, R1, R3, or R2, R4, whatever else. So suppose we know that values of two adjacent resistor, the other two resistance can be compared like this from this occasion. Okay. If three resistance are known, the value of unknown resistance, that is fourth one, can also be determined by this Wheatstone bridge. So now you may clear with that Wheatstone bridge. Wheatstone bridge is the important application of Kirchhoff rule. It is used to compare the resistance and determine the unknown resistance in the electrical network. Already we know that Kirchhoff first rule, second rule. Okay. So in that Wheatstone bridge, there are four resistors R1, R2, R3, R4, and four junction A, B, C, D, and one battery is there. That is AC EMF. Okay, it has EMF E. So applying that Kirchhoff first rule at the B junction and junction D junction, and again applying voltage rule for the junction AB DA and CB DC. From that equations, we have got uh, R1 by R2 equal to R3 by R4, which is the condition for bridge. Only under this condition, galvanometer shows null deflection. So G null deflection. G means galvanometer. Galvanometer null deflection. That means Ig is equal to 0. Only under this condition, Ig is equal to 0. Under this Ig is equal to 0, galvanometer shows null deflection, which is Ig. Okay. So this is a concept of Wheatstone bridge. Okay. Thank you, Bharat. Thank you, Jai Hind. Thank you, Vidyasati. Thank you.